Let's start solving from question number 16. X, Y, and Z are all the elements that are found in the group 13, 14, and 15 of the periodic table. X is in the same group as Y. Okay, so X and Y, you will see them as in the same group. Y and Z are in the same period. Okay, they have the same period and they have the same group. The first ionization of X is greater than the ionization energy of Y. So that means ionization energy of X is greater than ionization energy of Y. Melting point of Z is less than the melting point of Y. Y and Z both form a chlorides, which are white solids. These white solids, when they react with the water, they're going to form a pH of less than 4. Which row of the table show the possible identities of X and Y? Well, so here, since they said the X and Y are both on the same group, and ionization of X must be greater than the ionization of Y, that means X on the top of Y. So the best description over here should be the option A, which is boron and aluminium. Let's describe it further. If the Y is going to be aluminium, and they said Y and Z on the same period, so the Z must be phosphorus here. So they said Y and Z both form the chlorides, isn't it? So the aluminium chlorides and the phosphorus pentachloride, right? When they react with the water, they said they both react with the water to produce the solution with a pH of less than 4. So this will form phosphoric acid, right? This will form phosphoric acid, and when they react with the water, this will produce H plus ion, the proton, so which is more acidic, right? And both of them are less than 4 only. So the best description over here must be the option A. It cannot be the nitrogens. The option for the B should be aluminium because Z should be the phosphorus. Question number 17. Which row about silicon, magnesium and their ions is correct? Comparison of silicon and magnesium. So silicon is have magnesium and their ions is correct. Comparison. Silicon has a greater atomic radius than the magnesium. Silicon has electrons. See, first of all, we'll write the electronic configuration for the silicon. Okay. So when it comes to the silicon, which is in the group 4, isn't it? They are in the group 4. So we can write it as 1s2. So they have a number of 14. So we can write it as 1s2, 2s2, 2p6, 3s2, and 3p2, right? So this is total. And then if you're writing in the magnesium, magnesium is in the group 2. So its mass number is going, its proton number is going to be 12. And you can write them as 1s2, 2s2, 2p6, 3s2, right? And then across the period, the size decreases, isn't it? Therefore, silicon melting point should be greater than the magnesium. So we can say that silicon has a greater atomic radius than the magnesium. No. Silicon has a lower electrical conductivity than magnesium. No. The radius of the silicon is smaller than the radius of the magnesium. Silicon has a greater nuclear charge than the magnesium. Yes, you can go with the option D. You can say that silicon, because across the period, so if you check across the period, the size decreases, right? Across the period, the size decreases. Okay. So this silicon is having a chain structure. If you look at the structure of them, this silicon is having a chain structure. So it takes maximum melting point, and so it takes more melting point. Abandon. Silicon is having a joint covalent structure, isn't it? So joint covalent structure. So it has a high melting point. And if you check with the magnesium, it's having a lattice, like a metallic bonding it is, right? So its melting point should be less than the, so other options are saying silicon has a lower melting point. So this option should be wrong. And silicon has a lower conductivity than the magnesium. Silicon has 4 delocalized electrons per atom. Magnesium only has 2 delocalized atoms. The best option which suits here is the option D. So here, question number 18. Bromocresol green is an acid-base indicator. Below the pH of 3.8 is yellow. Above pH of 5.4, it is blue. Between these values, it is green. Bromocresol green is added to the aqueous solution formed when the chloride of element T is added to the water. The color becomes yellow. When an excess of the solid oxide of element U is slowly added to this yellow solution, indicator turns green, then blue. Which row could identify the element T and the element U? So here, the best option which describes element T and the element U should be silicon and sodium. Let's see why. They said here when the chloride of element T, so silicon chloride, okay? So silicon chloride when mixed with the water, you can say they added to the water, you're gonna form so you're gonna form your silicon oxide with the HCl. And when sodium oxide, okay, when the sodium oxide reacts with the water, we are going to form sodium hydroxide. And sodium hydroxide is the base and it will turn to blue color, isn't it? So added to the water, color becomes yellow. When an excess of this one, it is added to the yellow solution, the indicator turns green, then blue. So the best description option will be silicon and the sodium. Question number 19. Which row correctly describes the separate reactions of calcium and strontium, right? So when calcium reacts with water, you're going to get calcium hydroxide and hydrogen, right? At the same time, when strontium reacts with the water, you will get strontium hydroxide and hydrogen. Since you see strontium is below the calcium, so reactivity increases as you down the group. So more vigorous reaction should be for the strontium and the water. And now let's see which substance is oxidized and reduced. If you check for the strontium, uh, the oxidation state is 0, and here the oxidation state is +2. Similarly, for the calcium also, oxidation state is 0, and here it is +2. So the substance oxidation number is increasing here, right? Oxidation number increases means the substance oxidized is going to be either calcium or a strontium. So this option is correct, okay? And the substance which is reduced, so here H plus, right? H plus, and here it is 0. So it is +1 to 0. So it is decreases. So the substance which is reduced is going to be the water. Therefore, the correct option is D. Oxidation number increases means oxidation. Oxidation number decreases means it should be reduction. So the question number 20. L and M are both the compounds of the group 2 elements. L and M are both soluble in water. When solutions of L and M are mixed, white precipitate is formed. What would be the L and M? Okay. So let's go with the first option, which is barium chloride with the magnesium sulfate. When you react, it will form barium sulfate and magnesium chloride, right? So the barium sulfate is being insoluble, and it is insoluble and it is the white precipitate. So, and you also need white precipitate. A white precipitate is formed. So the correct option should be A. Why not barium sulfate and magnesium chloride? Because it is barium sulfate itself we cannot take because it is insoluble. We have to choose two, should be both soluble in the water. Barium nitrate and magnesium chloride, barium nitrate, it cannot form a proper insoluble salt, okay? And then barium chloride and magnesium nitrate, it cannot form a insoluble salt. Barium carbonate is a solid, so we cannot go with any other option. So option A. Question number 21. A 5-gram sample of anhydrous group 2 metal nitrate loses 3.29 gram in mass when heated strongly. Okay. So we will take metal nitrate. When you decompose them and when you are heating them, you're going to get metal oxide, and also you will get nitrogen dioxide and oxygen. And they both are gases. They just give away. Now they said 5-gram sample. So this is 5 gram. And group 2 metal nitrate loses 3.29 gram in mass when heated, right? So this is the metal oxide. So it will lose this much it will lose this much grams. Therefore, from the 5, if I minus 3.29 gram, I'm going to get 1.71 gram, right? So metal nitrate, and here I'm having metal oxide. So how much mass is left now? 1.71 and 5, right? So, and metal oxide, so metal, I don't know which one, but oxide is 2. So 2 into 8, which will be 16 I will get. And the denominator metal plus the MR of this total. MR of this total is going to be 2 into nitrogen plus 6 into oxygen will leads me to 124. So right here 124, which is equal to 1.71 divided by 5, and cross multiply. So, and just solve them. After you cross multiply, just keep solving them. So I'm going to solve them down here. So m plus 16 times 124. So m plus 124 times 1.71, right? So just cross multiply this. So which is going to be 5 times, so this should be 5 here, right? So it will be 5m plus 16 5s, it will be 80. So 1.71 m plus 124 times 1.71 will be 212. Therefore, 3.29 m is equal to 132 divided by 132, or m is going to be, if you simplify this, 132 divided by 3.29, which is equal to 40. So we know that 40 corresponding to calcium metal. So our correct option is going to be B. Twenty-two. In this question, Q represents an atom of a chlorine, bromine, and iodine. Which explanation of the variation in the volatility down the group 17 is correct? So if you see the chlorine on the top, followed by the bromine, then we have iodine, and the electron number increases as you go down the group. So as electron number increases as you go down the group, so instantaneous dipole, induced dipole forces between the molecules become stronger. So ID. So this is ID. Between the molecules become stronger. The only reason because the electrons are getting increased as you go down the group. Okay. Otherwise, you can say the van der Waals force between them will get increased. So the best option here is A. Permanent dipole force between the molecules becomes stronger. No, that's wrong. The bond energy of the Q2 molecules decreases. No, bond energy of the Q2 molecules increases because they're getting more stronger. Their density is increasing as you go down the group. Iodine is solid, bromine is liquid, chlorine is gas. Therefore, as the state changes, the density also increases. As the density increases, the bond energy to break the bonds also get increases. The first ionization of the Q is decreases. No, it will also increase. So the best option should be A. Question number 23. Which statement about the halogens or the halide ions is correct? Bromide ions react to form a white precipitate when added to the silver nitrate solution. Bromine does not oxidize the chloride ions when added to the sodium chloride solution. Yes, let's work. Bromide ions react to form a white precipitate when added to the silver nitrate solution. Let's see the equation for this. So the bromine with the sodium chloride, no reaction will take place here. Why? Because bromine is less reactive than the chlorine. So if you check the halogens as you go down the group, reactivity increases, right? I mean, the reactivity decreases. So the bromine is less reactive than the chlorine. So bromine cannot displace the chlorine from the reaction. So bromine does not oxidize the chloride ions when added to the sodium chloride solution. So the best option here should be B. Why not A? Bromide ions react to form a white precipitate when added to the silver nitrate solution because it will not form a white precipitate. It will form a cream precipitate instead. It will form a cream precipitate. Chlorine atoms form cations. No, it will not form a cation. Cations means positive ions. Chlorine is being a non-metal. It will form a negative ions. Negative ions are nothing but anions. They are going to gain an electron. Chloride ions are stronger. No, iodide ions are more reducing agents than the chloride ions. So the best option should be here, B. If ammonium cyanate is heated in the absence of air, the only product of the reaction is urea. No other products are formed in the reaction. What is the formula of the cyanate ion present in the ammonium cyanate? Okay, so the ammonium cyanate should be NH4 cyanate. So it should be CON. So it will be plus and this will be minus. So the ammonium cyanate ion should be OCN minus. So it should be C. Question number 25. Hexamine is a crystalline solid. It's used as a fuel for portable stoves. The diagram shows its skeletal structure. What is the empirical formula of a hexamine? Okay. So we know that there is one carbon here, another carbon here, 1, 2, 3, 4, 5, 6. So 6 carbon. And for the 6 carbon, there is every carbon has like the CH2, CH2. So every joints will have like this. And there are 1, 2, 3, 4 nitrogen. So empirical formula means we can simplify them, isn't it? So if I take 3 as common, so if I divide by 3 for all of them, no, we can't take as 3. So we just have to take 2 as the common number. So it will become C3 and H6 and N2. So your option should be C3, H6 and N2, so B. The compound aspartame is widely used as a sweetener in the diet soft drinks. It's a chiral compound. How many chiral carbon atoms are present in a molecule? So chirality means what? Chiral carbon atoms means they must have a different groups on each bonds, right? So we can say that here. Here you can see this is the chiral carbon as well as this is the chiral carbon. The reason is that it has 4 different groups, 1, 2, 3. Also, it has 1 hydrogen here. So 4 different groups are connected to the center. Over here also, 1, 2, 3. Also, you have another hydrogen which is connected to it. So these two are the chiral. So we can say the option is B. How many sigma and pi bonds are in the molecule? So in the molecule, so we need to draw the discrete formula of this in order to decide how many sigma bonds and the pi bonds are there. Okay, so here if you are drawing this part, so it's going to be H, C, and then between the C to the C there is a triple bond because the carbon valency is 4, and then we have this C, so we have CH2 which is connected to it. So CH2, again we have another CH2, and then we have CH. So then we have a double bond. So CH and CH3 and one here, and I will put one CH3 over here. Okay, so let's start counting them. So we have for the triple bond, we have totally start counting. So every single bond will have a sigma bond, and in the double bond you will have 1 pi and 1 sigma, and in the triple bond you will have 2 pi and 1 sigma bond. So let's count the sigma bond. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and one more was here, 19. So the option should be D with the 1 and 2 pi as well as 1 pi is over here. So the option is D. The hydrocarbon C17 and H36 can be cracked. Which compound is the least likely to be produced in this reaction? Which has to be D option, because there is no chance of getting C16 because in a cracking, one of the product must be ethene, and ethene must have 2 carbon in it, right? So 28 least likely to be produced in this reaction should be D. This compound has an MR of 84 and react with the HBr to give a product of 164.9. Okay. So if you check here, 1, 2, 3, 4, 5, 6. So there are 6 carbon and you will have 12 hydrogen. If you find the mass of them, to 12 plus 12 into 1, which is going to be 84. And if you're going to connect, fix the HBr into that, so it will be HBr means HBr is equal to 1 plus Br is around 79. You have to check it in the periodic table. 9.9. And if you add with this value with the 84, so I will exactly get 164.9. So the best option should be here D. Why not A? So here if you add A, you're going to get 84. And over here, if you add all of them, so 1, 2, 3, 4, 5, 6, 7. So C7, that means H14 will be there. So it will lead to a different answer than the 84. So anyway, here double carbon double bond is not there. So I can go with the option C. Beta carotene is responsible for the orange color of carrots. Beta carotene is oxidized by the hot concentrated acidified potassium manganate. And you know that Potassium manganate is a strong oxidizing agent, and it will help to oxidize to produce different products like ketones, carbon dioxide, carboxylic acid, like that. When an individual molecule of beta carotene is oxidized in this way, many product molecules are formed. How many of these product molecules contain a ketone functional group? See, in order to have a ketone functional group, it should have connected to some alkyl groups. Okay, alkyl groups. It can be CH3 or it can be C2H5, C2H5, anything. So as of now, you can take in your example, it is alkyl group is CH3. So try to look for the carbon which is connected to the CH3. As you can see here, this carbon is connected to this CH3, whereas this carbon is connected to another carbon, so you can't take that. And second carbon connected to the CH3 is here. So this is the third one, methyl group. And here fourth also methyl group connected. Here fifth one connected to the methyl group. Then sixth one connected to the methyl group. So here carbon double bond O, and this side it is connected to the another carbon, and whereas this side it is connected to the OH, so carboxylic acid. Okay. So therefore the answer is going to be 6. 31. 1,1-dichloropropane reacts with aqueous sodium hydroxide in a series of steps to give a propanol. Which term describes the first step of the reaction? Which term describes the first step of this reaction? So as you can see here, it's a haloalkane, right? So this is the haloalkane. It is reacting with the sodium hydroxide. So haloalkane reacts with the sodium hydroxide. So this is going to be your nucleophilic substitution reaction. So it's a nucleophilic substitution reaction. Okay. Therefore, your option should be D. Question 32. Propanoic acid can be made from bromoethane using a two-stage synthesis. Which pair of reagents is most suitable? Okay, so we have to make propanoic acid from the bromoethane, isn't it? So bromoethane, ethane, what is the formula of the ethane? It will be C2H6, isn't it? So CH3, CH2, so bromoethane. You have to make them react with the potassium cyanide. So you will get nitrides, right? So that you have to do in this is the first stage. This is the first stage. And the second stage, you have to do the acidic hydrolysis. Acidic hydrolysis. So to do the acidic hydrolysis, you have to take some acid. So that should be the dilute hydrochloric acid. So the option will be potassium cyanide. And the second stage is to do the acidic hydrolysis. So you have to choose the HCl. All right. Propanoic acid. Question number 32. Propanoic acid can be made from bromoethane using a two-stage synthesis. We just finished this now. 33. Alcohol X gives yellow precipitate with the alkaline. Iodine. What is the structure of X? Yeah, to form a iodoform test it is, right? So in order to give, so it should be secondary alcohol, isn't it? So it should be secondary alcohol, and the structure should be CH3, CH, and OH. So here, this structure is giving only in the option D, whereas here it's not. It's directly connected to the OH. It's not. So here you can see this is connected to the CH3. So this is not, this is not, this is not. So the best option will be D. Question 34. When ethanol reacts with sodium metal, ethoxide ions are produced. When water reacts with sodium metal, hydroxide ions are produced. Which statement about these reactions and the ethoxide ion is correct? So the answer should be A here, because if you look at this ethoxide ion, which you got it after the reaction between the ethanol and the sodium metal, and the water reacts with the sodium metal to form sodium hydroxide. Okay. At the same temperature, rate of reaction between the sodium and the ethanol to form the ethoxide ion is greater than between the sodium and the water, because here this is most stabilized one, okay, stable one, whereas this is less stable one. So the option should be A. Question 35. Menthol is a naturally occurring alcohol. When menthol is heated with a concentrated sulfuric acid, it reacts. The products include the structure T, the compound T. What is the structure of the compound T? Okay, so this menthol, when you it's an alcohol. When you react them with the sulfuric acid, actually it get dehydrated, right? It get dehydrated, so it will be the formation of alkene. It will form an alkene by a loss of water molecule. Okay, it will be dehydrated. It will form alkene here. So this OH, and there is a hydrogen here. This hydrogen and this hydroxide ion will react, and they will be combined to form a water molecule that will be lost. So this bond will be cut from here, and from this hydrogen will be cut, and this will be gone as a double bond. So you can draw the structure here. After losing a water molecule, this will actually be double bond over here. So matching to this structure here, A no, B no, C no. It should be D, and you can even cut this double bond here, and you can place them because it is always the alternative double bond. So the option should be D. Question 36. Which compound will produce the yellow-orange precipitate when added to 2,4-dinitrophenyl hydrazine? Okay, so it should be ketones, right? It should be a methyl ketone. So here the ketone will be, this is an alkene. So this is a carboxylic acid, and D is the ketone. So ketone will have this as the functional group. So the option should be D. Going to the question number 37, ethanol, it's an aldehyde when reacts with the addition reaction with the hydrogen cyanide in the presence of a cyanide ions, which row identify the type of reaction and the name of the product formed. Okay, so it should be a nucleophilic addition reaction. Nucleophilic addition reaction. So the option should be C. Let's see the structure. CH3, C, H, O. It addition reaction with the hydrogen cyanide. So what is the product you're forming here? This hydrogen, this cyanide will be make a bond with this one. So addition hydrogen will join with the O, and it will form as a hydroxide ion. So it will be CH3CH. Here OH will be formed. Here Cn. So how many carbons? 1, 2, 3. To the second carbon, hydroxide group is added. So you can name them as 2-hydroxy-propane nitrile. Okay, 2-hydroxy 1, 2, 3 propane nitrile. Nitrile because of the cyanide. Okay, so your option should be C. Question 38. Structure of compound X is shown. What is produced when X is heated with sodium hydroxide? See, this is an ester, right? When ester is heated with the sodium hydroxide, it is hydrolyzed, and it is going to form sodium salt of carboxylic acid and alcohol. Okay, sodium salt of carboxylic acid and alcohol. So if I break down this here, this H will be OH. So you will have a OH group and a sodium salt of carboxylic acid, which is COONA, sodium salt of carboxylic acid. So if you break this bond, so here OH, OH, and then this. So we have this here, and then this one, so same as here. And then we have this part is COONA. So the best option should be C. So it is going to form sodium salt of carboxylic acid, COONA plus alcohol. So the both can be described well in this. So COONA, COONA, and the alcohol. So the option should be C. Question 39. Infrared spectrum of the compound L is shown. So here the bond is given, functional groups and the characteristic infrared absorption range is given here. And your question is, what is the structure of L? So here if you check, the broad peak is going to be 3200 to 3600, which is for the hydroxy group, OH group. So here your correct option going to be C, because they have provided with the hydroxy group. and carboxyl hydroxy group for the C. And why not it is A? Because they have got CO bond. That means carbonyl, carboxyl peak is absent here. Okay, carboxyl peak is absent. So carboxyl means the C double bond O. So the A is wrong, B is wrong, C is correct answer, as well as the D is wrong. You can't see any carboxyl hydroxy group, so D should be wrong. The mass spectrum of a compound J, the ratio of the height of the n plus 1 ion peak to the height of the n plus ion peak is 4 is to 91. Compound J forms a carboxylic acid when heated with acidified potassium dichromate. What is the compound J? So what is the compound J? So here, let's find the number of carbon atoms present. So number of carbon atoms present. So number of carbon atoms, let's find that using the formula we already have it. So 100 divided by 1.1 into the abundance of n plus 1 ion to the abundance of n plus ion. Right? Therefore, it will be 100 divided by 1.1, and here it is 4 is to 91. So 4 by 91, it will give me n around 4. So we understood. It should be an aldehyde made of 4 carbon atoms. So CH3, CH2, CH2, and CHO. When it is oxidized using the potassium dichromate oxidizing agent, okay, it is going to form butanoic acid, right? So it will be, the result will be butanoic acid. So your best option will be here, A. Okay. So propane 1-ol, butanol, propane nitrile, we cannot get that result. So the best option which describes this will be carboxylic. So it will form a carboxylic acid is only the butanol. So butanol will form butanoic acid when you oxidize using the potassium dichromate. I hope you understand the video. If you like the video, don't forget to subscribe.